Okay, we're set. This marker is not crisp. Okay, but that's okay. I have some here. Okay, I have some here. Let me try this for a little bit more, but it doesn't seem to be crisp. Now, Hess's law allows us to kind of play with and manipulate chemical equations. For instance, let's say this is really what we want to find the thermodynamic quantities of. We want to know what the enthalpy is for this. Okay? We want to know what the change is. So maybe we can't do this directly in a laboratory. So what we do is we do other equations that are in a laboratory. Clear? We do other equations that are in a laboratory. And then we use these two equations to literally mathematically produce the equation in question. That's all it is. Is there a way that I can somehow add these two equations to come up with this equation? Does anything strike you as being peculiarly algebraic? Yes?
I may be wrong, but like the elimination.
You may be wrong, okay, because it looks kind of easy, but yet it's a topic you've never studied before, Hess's law. So what's your intuition say, Eden?
With both of them, I don't know, we could do like the elimination method.
Elimination method, kind of like simultaneous equations?
Yeah.
Yeah, exactly. You're right, your intuition serves you well. So you see that the SO2 is over here, and I have 1.5 moles of O2 here, but I only need 1 mole. But if I reverse the bottom one, right, I could cancel 0.5 mole of O2, and I could cancel the SO2, right? I mean, I get the SO2, I would get the SO2, and I'd cancel the SO3. See that? So shall we try that? Okay. So what I'll do is, I will use the magic of the whiteboard and just reverse this. Okay? So what I'll do is, I'll reverse this. Okay, I'll rewrite things. Right, I'm going to rewrite the SO2 over here. SO2. And then I'm going to say 1/2 O2 plus that. And then this is going to be the SO3, right? Is that correct, or did I do something wrong? Did I reverse it? Using the magic of the whiteboard? Right? Look at your original equation. Wasn't it 1/2 O2 and plus SO2? And then I reversed it. Didn't I?
Yeah.
Yes or no?
Yeah.
So I can go like this, correct? I can go like this. And what am I left with? I'm left with sulfur. I'm left with O2, just one O2, correct? And I'm left with SO2. That's all I did. Now, you reverse the direction. Remember, this is kind of binary. There's only, zeros and ones here. In other words, there's only plus or minus here, isn't there? So if it's negative 98, if I reverse it, it would be what? It would be positive 98. So you reverse this equation, you simply reverse this, and then when you add them. So what is going to be negative 395 and a positive 98?
Negative 297.
What is it?
Negative 297. 297.
And is there anything else there that needs to be discussed? Negative 297. Yes? Isn't that essentially what they did? Correct? They just added them. How'd I do?
Is that it?
That's it?
Easy?
Yes.
Oh, that's not that hard.
Well, I was allowed to use the whiteboard, so I could just kind of make quick changes. But here, they rewrite everything, but it's the same thing.
So
Yes, yes.
What's all this with the change in enthalpy 1, change in enthalpy 2, change in enthalpy 3? Like, why is it so complicated like that?
It's not complicated. This was enthalpy 1, this was enthalpy 2. I took enthalpy 1, I took the additive inverse of enthalpy 2, and I came up with enthalpy 3. That's all I did. I think the book
Overcomplicates things?
way overcomplicates things. Way overcomplicates things. Did you understand what I did on the board?
Yeah.
That's it. There's nothing else. Now you're going to want to do some practice, but let's move on, shall we? Can we click this off? This was Hess's law
In practice.
in practice.